You sits down at a table, sears a thick steak in a sizzling skillet, and shoves a tender, juicy piece straight into your mouth. It tastes incredible, rich, savory, deeply satisfying. But stripped of the quiet kitchen and the polite silver fork, a stark biological reality sits on that plate. For that single moment of pleasure and nourishment, a living, breathing creature had to be slaughtered. A knife had to cut, blood had to drain, and a heart had to stop beating. Why? Why does life on Earth work like this? Why does human survival and the survival of every predator on the planet depend on the violent death and suffering of another creature? Look around the biosphere. Earth is not just inhabited by life, it is saturated with predators. Orcas tearing through ocean swells, eagles dropping from the sky, wolves hunting in coordinated packs, spiders waiting in darkness, and microscopic parasites tearing into host cells. From the deepest ocean trenches to the highest mountain peaks, survival on this planet is relentlessly, brutally built on killing. Think about this for a second. Why is the entire world organized like a gladiatorial arena? Why couldn't life have evolved as a peaceful global meadow where every creature simply soaked up sunlight or quietly grazed on plants? Why did nature choose savagery as its primary engine? It sounds like a moral mystery, but the answer isn't philosophical. It comes down to first principles physics, thermodynamics, and the brutal arithmetic of biological survival. To understand why the world is full of carnivores, start with the ultimate power source, the sun. Sunlight hits the earth, and plants perform photosynthesis, converting solar radiation into chemical energy. Plants are primary producers, sitting at the absolute bottom of the energy pyramid. On paper, living strictly as an herbivore seems like the ultimate evolutionary strategy. Plants don't run away, they don't bite back. A plant never broke a predator's jaw or tore a predator's eye out in self-defense. So why isn't every creature an herbivore? Because plant matter conceals a massive biological trap. It is exceptionally difficult to turn into usable fuel. Plants construct their bodies out of cellulose and lignin, tough, fibrous structural molecules that are absurdly hard to digest. To extract energy from leaves or grass, an animal has to spend almost its entire life chewing, grinding, and fermenting fiber. Look at a cow or a gorilla. A cow spends up to 8 hours a day doing nothing but chewing cud, relying on a massive, four-chambered stomach full of specialized bacteria just to break down tough plant walls. A gorilla spends half its waking hours consuming up to 40 pounds of vegetation every single day, dragging around a massive, swollen gut just to digest low-calorie leaves. Herbivory is a low-risk, low-reward strategy. It offers a slow, tedious trickle of energy, but it requires an enormous metabolic investment just to process the food. Carnivory is nature's ultimate thermodynamic cheat code. Flash is not like grass. Meat is pre-packaged, pre-concentrated, high-density fuel. When a predator eats another animal, it skips the agonizing process of breaking down plant cell walls. The prey has already spent months doing the hard labor of converting thousands of pounds of plants into dense muscle tissue, fats, proteins, and vital nutrients. Gram for gram, flesh provides vastly more energy than foliage. What takes an herbivore 12 hours of constant grazing to extract, a carnivore acquires in a single 20-minute meal. That energy density changes everything. It frees up time, slashes the required size of the gut, and unlocks massive amounts of metabolic budget for evolution to build better biological hardware. Consider what this specific metabolic shortcut did for humanity. If there is one species on Earth that owes its existence to the evolution of carnivory, it is human beings. 2 to 3 million years ago, early human ancestors lived on fruits, seeds, and tough vegetation in the African savannas. They had small brains, massive jaws, and long, heavy digestive tracts designed to ferment plant fiber, much like modern chimpanzees. But as the climate shifted and dry grasslands replaced lush forests, high-quality plant food disappeared. Hominins faced a binary survival choice: either adapt to eat low-quality grass or find a denser energy source. They chose meat.
First, by scavenging carcasses, smashing open bones with rocks to suck out high-fat marrow, and eventually by active, cooperative hunting. This shift triggered what scientists call the expensive tissue hypothesis. In the human body, two organs consume a disproportionate share of daily calories: the brain and the gut. Both are incredibly expensive to maintain. A huge digestive tract is mandatory if an animal lives on low-quality plants. But when early humans began eating dense animal fat and protein, that huge gut was no longer necessary. Over thousands of generations, the human digestive tract shrank dramatically. The metabolic energy previously locked up in maintaining a heavy, long digestive system was suddenly liberated. Evolution funneled that newly available energy directly into the brain. Without animal flesh, the human brain could not have expanded to its present size. The human brain consumes roughly 20% of the body's daily energy, while accounting for only 2% of its total weight. That level of neurological processing power requires a rapid, highly concentrated fuel supply that an early plant-only diet could never deliver. And the compounding benefits didn't stop there. Hunting required tracking, communication, toolcraft, and social coordination. The pursuit of meat forced early humans to become strategic, vocal, and deeply cooperative. Carnivory didn't just feed the brain. The demands of acquiring meat actively sculpted human intelligence. When humans discovered fire and began cooking meat, digestion became even easier, acting like an external stomach that broke down proteins before food ever entered the mouth. Why did biology make carnivory essential to the whole planet, not just to humans? Why couldn't ecosystems balance themselves without blood being spilled? The answer lies in systemic control. Without carnivores, ecosystems collapse under their own weight. This phenomenon is known in ecology as a trophic cascade. When top predators are removed from an environment, herbivore populations explode out of control. Left unchecked, herbivores eat plant life faster than it can grow back. They strip forests clean, cause massive soil erosion, destroy river systems, and eliminate the habitats of thousands of species of birds, insects, and small mammals. Eventually, the herbivores deplete their own food supply and face catastrophic mass starvation. Carnivores function as the ecosystem's ultimate safety valve by controlling prey numbers and altering their behavior, forcing herds to keep moving instead of overgrazing a single valley. Predators preserve the health of entire landscapes. Beyond population control, predation is the primary engine of biological innovation. Evolution is an arms race, and predators are the ultimate pressure test. An herbivore does not evolve lightning speed, acute hearing, camouflage, or complex herd strategies to outsmart a field of clover. It evolves those traits to escape teeth and claws. In response, predators are forced to evolve sharper senses, better stealth, strategic intelligence, and superior physical coordination to catch adapted prey. Savagery is the biological grindstone against which life sharpens itself. Without the constant threat of death, the pressures that created complex animal intelligence, agility, and sensory beauty would disappear. Life would stall. This brings the argument to the critical counter-question. Was it worth it? What are the dark sides to a biological system run on carnivory? The reality is that carnivory is an extraordinarily risky, inefficient, and dangerous survival model. First, consider the brutal failure rate. Pop culture portrays predators as flawless killing machines, but real biology is far less forgiving. A lion fails up to 80% of its hunts. A cheetah misses more than half the time. A polar bear can wander across freezing ice sheets for weeks without making a kill, burning through precious fat reserves. For a predator, every attempt to eat is a high-stakes gamble. Failure means starvation, and success often carries the risk of severe injury. A broken bone, a gouged eye, or a deep wound suffered while struggling with prey is almost always a death sentence in the wild. Herbivores face almost zero physical threat from their meal. Carnivores risk their lives every time they eat. Second, carnivory suffers from extreme thermodynamic vulnerability, governed by the 10% rule in ecology. Only about 10% of energy at one level of the food chain is transferred to the next. It takes thousands of pounds of grass to grow a few hundred pounds of deer, which can only support a single wolf. Because apex predators sit at the tiny tip of a massive energy pyramid, they're hypersensitive to environmental disruptions. If a drought hits or prey populations dip, top predators are always the first to starve. Third, carnivory faces heavy biological costs from pathogens and bioaccumulation. Toxic compounds, heavy metals, and parasites concentrate as they move up the food chain. Consuming raw meat also exposes animals to lethal infections that plant eaters rarely encounter. Finally, for humans specifically, carnivory created a profound existential rift. The evolutionary engine that forged the human brain through hunting eventually produced a mind capable of empathy, moral reasoning, and compassion. Humans became the only predator on Earth capable of looking at a plate of food, realizing a living creature had to suffer and die, and feeling genuine moral distress. This creates a deep psychological tension. Humanity carries a biological framework built on prehistoric predation, operating within a conscious mind that longs for peace and kindness. Modern industrial farming, ecological destruction, and ethical debates over meat are the direct friction of a civilized mind wrestling with ancient biological wiring. So, looking at the physics, the evolutionary history, and the biological math, was it worth it? From a purely practical standpoint, the answer is absolute. Without the thermodynamic efficiency of meat, the human species as it exists today would not exist. There would be no art, no philosophy, no technology, no space travel, and no conscious brain sitting down to ask why life is so brutal. The savagery of nature was not a cruel mistake or a biological flaw. It was the necessary engine of biological progress. It was the only way for energy to be concentrated and compressed enough to power complex brains, razor-sharpened instincts, and dynamic ecosystems. The natural world runs on a blood-fueled engine. Life reaches absolute peak of intelligence and awareness not despite the violence, but because of it. So the ultimate question remains. Now that humans possess the self-awareness to recognize the blood-fueled engine of nature, does humanity have a moral obligation to eventually outgrow it? Or is savagery an inescapable part of human biology? Drop a thought in the comments below on whether a civilization can ever truly leave its carnivorous origins behind. If this perspective on evolutionary biology gave you something to think about, hit the subscribe button to join the channel. Interestingly, the very brain meat built didn't just change how early humans ate, it transformed how they lived together. For hundreds of thousands of years, early hunter-gatherer bands roamed the planet with no bosses, no laws, and zero rulers. Yet today, almost every human alive is governed by authority. Click the video on screen right now to explore how humanity transitioned from stateless hunter-gatherers to being ruled by the very first leaders in history.